to quadratic functions, sorry, that needs to go away, to quadratic functions. So if you look, y equals a parentheses x minus h squared plus k. So when you were doing that activity that was on Desmos, notice I just wrote that same equation. Each of these numbers is going to do something different. So let me rearrange that so that it's A, H, and K. So if I put the A at 1, actually let me just go ahead and make another one that's the parent function. Y equals x squared. So there's the parent function. I want that to be at 0. I want that to be at 0. So when you're looking at the parent function, this is currently the parent function. We have a is 1 because it can't be 0 when you're multiplying. That would make all of that 0. So h is 0, k is 0. As I shift each of these, it does something different. So if I move my h, notice it's a horizontal shift. So just keep that in mind. The h is moving it left or right. The k moves the vertex, and when I say it moves it left or right, I'm talking about the whole parabola. The parabola is moving down or it's moving up when I move the k. The a value makes it skinnier, which we call that, this is a stretch, this is a compress. Okay, so keep that in mind. So transformations, and we just use a letter so that whenever there's a number in this spot, like if we look at this one, the number that's here we identify as A, the number that's inside of the parentheses we identify as the H, and the number that's adding or subtracting at the end is the K, and each of those numbers do a different thing. So I'm going to go ahead and write this out. So the A, when you were doing that activity, you should have seen that it stretches when it is larger than 1. When A is, it compresses when it is smaller than 1. When it's negative, it reflects over x-axis. Okay, so what I think about whenever I think about a negative, I think about like somebody when you're smiling or frowning. So if I smile, the parabola, I'm positive, is the way I think about it. So if it's negative, it reflects over the x-axis. So instead of it opening up, it's going to open down. Oops. Okay. Now, and that's if, again, what the A means, if it is smaller than 1 or if it's a fraction like 0.5, notice it's wider, or 0.4. If it's negative, it opens down like a frown. That's the way I say it. It opens down like a frown. This one opens up. Okay? The H, notice, and I'm going to make that a positive. The H moves it left or right, but remember it's the opposite direction. So when it is a positive 2, it actually moves left 2. So H is called a horizontal shift or translation, and it's always the opposite. Oops, I forgot I was not on my document camera. So it's a horizontal shift or translation, and it's opposite. So if it is positive, it moves left. If it's negative, it moves right. And that's when the number is inside of the parentheses. Okay, now we're going to look at K is a vertical shift or translation. And this one is not opposite. So if it is positive, it moves up. If it's negative, it moves down. So let's look at this. So if the k is positive 3, notice the vertex is 3 up. If it's negative 3, the vertex is at negative 3. All right, so now that we have written all of those out, the a, the h, and the k, let's look at this example. Y equals 1/6 parentheses x plus 4 squared minus 2. I like to identify the letters so that 1/6 is in the A position. Sorry, I'm writing my A so weird. I don't know why I'm doing that today. But the H is inside of the parentheses, and the K is adding or subtracting at the end. Now, I use graph paper, so if you don't have graph paper, just make a quick sketch of it. That's fine. So the A is positive, and it's a number smaller than 1, so that means we're going to compress by a factor of 6. So it compressed by a factor of 6 because the denominator is 6. The H is positive 4, and so it's the opposite, so we're going to move left 4. And the K is negative 2, so we're going to move down 2. Now, you can't compress or stretch, so you can't compress, which remember it's like squishing Play-Doh. It's making it wider, where if I stretch it, it's making it skinnier. So it's compressing, you have to compress it after you find the vertex. So from the origin, we're going to move left 4. So 1, 2, 3, 4. And then we're going to move down 2. So that is our vertex. Now, since it's compressed by a factor of 6, you're going to move over 1, kind of like the slope. So but you always move over 1, and then we go up a 6th, so around in there somewhere. And then you have to do it the other side, because remember it makes that U shape, that parabola. So I'm going to go over 1 and up a 6th. And that's what our parabola would look like. Okay, remember when we were, I wrote this note on the back side of this paper, but remember when you were doing the tables, you can always do that, but think about these equations. They're pretty hard, so in order to write the table for that, it would be quite a bit of work. So you can always do that, it's an option, but that's why I like using the transformation. So now let's do one more example. So if I have 4, which is our A, now that number is larger than 1, so that's going to be a stretch. 3 is our H, which that's negative 3, so you're going to move right, because remember it's the opposite. And then the K is positive 2, so that would move up. Okay, so find your vertex first. So I'm going to move right 3. Oops, did I go the wrong direction on that last one? I did, darn it. So I just realized I went the wrong direction on that one. I didn't even move left. Apparently I don't know my direction. So let me fix that real quick. 1, 2, 3, 4. And then down to 1, 2. So it should have been right there and right there. See, even teachers make mistakes. Don't let anybody tell you otherwise. So, sorry about that. I'm sure that some of you might have already paused the video and told me I made a mistake, but I wanted to make sure everyone was aware of that. So this was the wrong direction. I didn't go left, because remember, if it's positive, it has to go to the negative side. All right, let's go back up and let's finish this one. Sorry, let's try that again. So right 3, 1, 2, 3, and then up 2, 1, 2. So this is our vertex. We went right 3, 1, 2, 3, and up 2. Then our A. Always move over 1 and then up by A. And you probably want to highlight that, but so we're going to move over 1 both directions. So move over 1 and then we're going to go up 4. 1, 2, 3, 4. Over 1, 1, 2, 3, 4. So notice that one is definitely stretched. So it's, again, like Play-Doh. So instead of being the parent function like this, it's stretched. You're taking that Play-Doh and stretching it out. If it's compressing, you're squishing the Play-Doh. You're making it more flat. So again, you could always do the tables. And if you look back at the notes that you took from the tables, I don't think we did any where we did all of them, but you could see that you could do the same thing. It's just it moved it. It's easier to identify it by the A, the H, and the K.